So, hi everyone. My name is Ana Maria Jaramillo. I'm part from the Networks Inequality group at the Complexity Science Hub in Vienna. And today, this is one of part of our lecture series meeting. And today, Balázs Lengyel is going to present us, and he was going to be in person, but now he is here, and I give the floor to you, Balázs, for your presentation.
Thank you so much, Anna, and hello, guys. First of all, I would like to say sorry that I couldn't go today. The train connection is still very uncertain between Budapest and Vienna. So I checked a couple of days before, and yeah, it was not clear how that operates. So I thought it's better to don't be late, at least with the talk. And to be on time, and I hope that we can meet in person soon, as we agreed with Anna that we will organize something together. So I'm an economic geographer. See some economic geographers in the room, so it's very good to have you guys there. But I'm interested very much in social networks and networks in general, and I'm very happy to present a couple of works to you that aim to focus on inequalities in social networks, which I know is a central focus of your team, and I'm happy to hear your comments and questions and ideas. So my general starting point is that we live in small world networks, and we all know what small world networks are. And in such small world networks in which most of the connections are concentrated within geographical space and within small circles of friends and relatives, there are bridges that connect these groups, which makes the world very small. So in such a world, in such a small world network, viruses and innovation, information is diffusing very fast due to these bridges. However, we see also an increasing segregation in global society, increasing inequalities. So the question of the talk and the question for my research in general is, why do we observe such growing inequalities if diffusion of ideas or knowledge should be very quick in small world networks? So that's the main question, and of course, we are not the only ones who ask this question. The mainstream of the sociology discourse has an answer for that, and basically the answer is that even the networks, the global social network, is very small. It's fragmented by groups, and one of the strongest force that fragments the social networks is prosperity, which comes with the following consequences. So if the social network is fragmented by prosperity, then even though we assume or expect fast diffusion in the network, these fragments have a major obstacle for the diffusion, and ideas, innovation, prosperity will not spread across social groups. So, for example, in this plot that is famous from the Econometrica paper of Matthew Jackson and colleagues, they looked at the friendship networks within US high schools, and in these friendship networks, we see these fragments emerging, which are basically formed by ethnic background. So if you look at this plot on the left, which is like a stylized summary of the theories that are behind and the mechanisms that are behind, the major mechanisms of social network formation, as we know, are similarity and network closure. And if there is a characteristic dimension of similarity that fragments the networks, and if that is basically prosperity, then fragments in such social networks will be polarized by that they will form around that dimension, and then the global social network will be polarized by that dimension. So the basic question is that we should ask here how this mechanism operates in social networks, and how can we break it. So, for example, if instead of the only force of network fragmentation, there is some bridging as well across the groups that we see emerging, then a question is, how do those bridges help social mixing and mitigation of inequalities? Because if only fragmentation is happening, then we see an increasing, ever increasing inequalities, because then polarization will lead to a stronger effect of similarities and not bent to network fragmentation, and so on and so on. Of course, this process is happening in geographical space. So just sticking to the example of US high schools and looking at the map of Detroit, we can hardly imagine that a guy living in this neighborhood will get to high quality education similarly to those guys who live in other parts of Detroit. So segmentation, segregation happens in geographical space in urban societies. So we want to add that element to our research, and you will see how we managed to do that. And that's kind of one of the major streams that our group is doing at the moment. Because we live in a world in which geolocated data is coming to dominate, I would say, or at least contribute vastly to social science research. We trace individuals by their mobile phone movements, by their credit card transactions, and you can name a lot of more interesting data sources that can help us understand how urban societies behave and how dynamics of inequalities change over time. So, for example, research is focusing now on how individuals mix and where individuals from different strata mix in the city, and how this is connected to congestion, car congestion in the cities, and how we can mitigate that. One of the papers that recently came out in this 15-minute city concept basically says that if we want to fight car congestion, then we will automatically increase segregation in cities, because then we will make it more difficult for segregated groups in the urban space to mix and meet each other in cities. So this is basically a general introduction that I wanted to share before going to our research, because that's something we want to combine in understanding how social network dynamics and social network structure is correlated with inequalities, and how network fragmentation can be fought with bridging and social mixing cities. So one of the papers that we did a couple of years ago, basically this was the first paper in this topic that was led by Gergő Tóth and Johannes Wax. You see these guys on the screen. Was published in Nature Communications, and in this paper we analyzed an online social network which was specific to the Hungarian context. So let me tell you a little bit about this data set, because we published at least 10 papers out of this data, and I always promised to myself that I will never touch the data again, but it's still ongoing. So the data is very rich and very promising in many other fields and many other for many other ideas. So if you have some idea, then feel free to reach us. Okay, so this data is like a Facebook comes from an online social network which looks like Facebook and the old type of Facebook. We have 2.8 million users who registered a profile in the 2000s, so before Facebook, and we know their location on the town scale, town level. We know the date of registration, date of last login, the ID of friends, so we can construct the social network. We also see who invited the person to register the profile on this social media site. So we can see how this diffuses in geographical space and how it declines. One interesting element that we added a couple of years ago is that we found that geographical barriers are indeed impacting the social connections. So, for example, here you can see Lake Balaton, the biggest lake in the country and probably in Central Europe as well. So you see that individuals on the northern side of the lake know each other across towns, but they don't really see, they don't really know individuals living on the other side of the town, lake, I'm sorry. So geographical barriers matter, and this we'll come back the second part of the talk, in which we're gonna see a little bit how we think about the role of geographical barriers in urban spaces as well. So in this paper, we zoomed into towns, Hungarian towns, and quantified the level of fragmentation in the social networks that we see in this social media network within the town. So here you have two examples, Gödöllő and Ajka, two Hungarian towns of around 30,000 inhabitants. Gödöllő has a relatively unequal income distribution that you see in plot A, and also a relatively fragmented social network compared to Ajka, which has a relatively less unequal income distribution and a relatively less fragmented social network. So please note that here network fragmentation is based on a community detection algorithm that network scientists usually know what, so that's the Leuven algorithm. So that one of the most popular algorithms to detect communities in large networks. However, this algorithm is difficult to compare across towns because you cannot really compare the modularity value that this algorithm provides you to capture how segregated these networks are. So we compared this modularity index to the theoretical maximum that would come from the network partition that enables us to compare towns, the network fragmentation of towns of different sizes. So here we have relatively similar number of communities that we see in these two examples, but what we see that in Ajka, these communities are much more tightly knit than in the case of Gödöllő. So we found that this network fragmentation index is correlated with the Gini coefficient of the income distribution of these towns, which was already a nice signal that probably these two mechanisms of income distributions and social network formation are interrelated. However, a more important finding in this paper was that if you look at the subsequent value of the Gini index in the town, and we estimate that in a simple linear regression framework with the initial value of the town's Gini, and then the network fragmentation index that we get from the social networks and their interaction term, and we had a couple of control variables, of course, then we see that network fragmentation has a positive correlation with the following level of the Gini index only in those towns where Gini was already high in the beginning. So that means that even if we cannot really demonstrate that circular argument of network fragmentation and inequality dynamics, we see that the rising inequality happens only in those towns more that have fragmented networks and high initial values of inequality, meaning that probably that circular mechanism might be at play, such that if there are poor and rich communities in social networks, they have difficulties to mix, and therefore individuals in these towns cannot benefit equally from social networks. Because we are geographers, we were interested in the role of urban topology as well. So we looked into, because if on the macro scale at least, had this interesting insight in which we could see that geographical barriers matter, we were interested whether geographical barriers within the city matters for social network formation as well. So what we did was that we quantified the fragmentation of the residential areas within Hungarian towns, and quantified whether the town is segmented by major roads, rivers, or railways, or not. So in the case of Kaposvár, which is a university town for around 50,000-60,000 inhabitants, you see that there is at least 2-3 major highways going through the city. There's a river, there's a railway, which are by definition barriers to local mobilities, because probably it's for a child, it's very difficult to get from this part of the city to the other part of the city if she or he wants to play with her or his friend. And probably it's also difficult to get to the other side of the railroad if you are only walking. On the contrary, in another university town in Veszprém, which is the same size, the major road doesn't go into the city center, and the railway is also outside of the city. So we see much less spatial segmentation or segregation of this of the town of downtown. So face-to-face meetings or social mixing should be easier. So an interesting finding was that indeed in those cities which have more fragmented topologies, they tend to have more fragmented social networks compared to those cities or towns which have less fragmented urban topologies. Another indicator that we used to understand why some towns have fragmented, other towns have less fragmented social networks was the spatial concentration of amenities, because probably you visit some amenities in your city where you can meet with others who live in the same city. So the two competing arguments, whether spatial concentrations should help or help social mixing or not, is the following. Probably so some economists say that in cities such as Szentendre, in which the amenities concentrate in the city center, individuals living outside or at the periphery of the city have less access to these amenities, so they also have, by definition, we can assume that they have less access to social networks as well. The other argument, coming from more the urban studies community, is basically is the following: if you have an amenity distribution in which some amenities can be found in more peripheral areas of the city, by definition we can assume that the social network will be fragmented, because individuals do not have to go into the city center, so they will only visit their neighborhood amenities, which might lead to more segregated or fragmented networks. So we checked these assumptions or these hypotheses empirically, and we found that in our case, in our specific case, the spatial concentration was correlated positively with network fragmentation. So basically, those towns where amenities were concentrated in the city center were more fragmented. Interestingly enough, these urban structure or urban topology indicators described or explained the level of social network fragmentation in our towns better than other dimensions of similarities or differences in the town society, such as school inequalities, political fragmentation, religious fragmentation, or ethnic fragmentation. So that tells us that probably there is something indeed in this story that people need to mix in cities to develop healthy social networks. So we put the whole story into the IV estimation framework, and I should emphasize that what we have is not what most economists would say as a proper identification strategy, but due to the lack of data and especially the lack of network dynamics data on network dynamics, this was the best what we could do. But we actually found that most of the or all of the urban topology indicators worked fine as an IV, as an instrumental variable, in which we first estimated social network fragmentation in the city, and then used the estimated value of social network fragmentation to explain Gini in the town. Which this whole story tells us that probably there is an interrelatedness between urban topology, network fragmentation, inequalities. Therefore, we got very excited about similar topics. So one of the questions we wanted to ask, what is the relationship between income, social networks, and urban mobility? For that, we needed better data. So we needed better data on a finer scale that could help us map social networks and geolocate social networks within cities, because the problem with the EVF data was that the geolocation was only on the town level. So for that, we used a Twitter data source that colleagues in Budapest at the Eötvös Loránd University collected and claimed that it included all geolocated tweets between 2013 and 2015. So we used that data source, we got access to the data source, and zoomed into US metropolitan areas. This work was led by Eszter Bokányi and Sándor Juhász. You will have Sándor, as I know, tomorrow, so please say hi. So they geolocated all the tweets and identified home locations and home of friends by this clustering algorithm that basically pulls together those tweets that are within close proximity, and by grouping those geographical locations where these users usually tweet in evening times versus we can also identify work locations by just focusing on those tweets where users tweet in typical working hours. So we know where individuals, or we can estimate where individuals live, and using US census data on the census tract level, we can also have an estimation about their socioeconomic status. So using this data set, we looked into the differences between the social network structure between those individuals who live in a relatively low income neighborhood and compare that to those guys who live in relatively high income neighborhoods. And what we found that those individuals who live in relatively low income neighborhoods have a more geographically more concentrated social network on average, meaning that probably the social capital concentrates more in those areas where neighborhoods are typically poor relatively, compared to those neighborhoods where relatively richer guys live, who have a more geographically more widespread social network, much more diversity in the social network, and which should come with much more benefits and so on. There is a huge literature in economic geography and also in economics and computational social science about this the geographical benefits of geographical social ties. So we found this, meaning that probably there is the social concentration is something that we might, or geographic concentration is something that we should consider when we think about network inequalities in cities. However, individuals move in the city, right? So they go and visit places, meet friends, go to work. And going to work, commuting is basically one of the most important moves that individuals do when they go from home to their work location. And these two locations, home and work, are basically the two locations where they spend most of their time. So in order to understand a little bit how commuting can contribute to social network structures, we looked into the social networks of the 50 largest US cities and divided our individual observations by those who commute less than the median in the city to those who commute more than the median. D is the distance of the commute, so the distance, geographical distance between home and work. In most of the cities, we found that the average local clustering of the individuals is higher for those who commute less than the median. And we know that local clustering really captures the number of closed triangles in one's social networks. So these guys who commute less than the median have more cohesive social networks. However, what we see also that those guys who commute less than the median have a much lower, significantly lower in most of the cities, a significantly lower income difference within the ego network. So basically, the friends are more similar in terms of income than in those cases where the individuals commute more than the median in the city. And this whole story tells us that if you commute more, then you probably meet others who are less similar to your socioeconomic status, right? So then you can probably establish some bridging ties to other social groups in the city. So let me jump a little bit here. I don't want to go into details about this slide. We just one sentence basically. So we found that commuting, however, although commuting can induce some bridging ties, we still have a relatively big social network fragmentation measure, or a segregation in terms of the social network in cities as well. If you are interested in the paper, it's out in scientific reports. However, the time is running, so I wanted to touch a little bit about the urban mobility leg of this whole research stream that we want to push here, because we think, and personally, I really, I strongly think that urban mobility can help us understand how social mixing in general and social network dynamics in particular help to establish healthy social networks in cities. So for that, and then again with the leadership of Sándor, we looked into a data source that can trace individual mobility. Basically, we can follow individual mobility over the day of a couple of thousand individuals in Budapest. And the question was, do we see those specific places in the city where individuals tend to mix and social groups, socioeconomic groups can mix? The finding was that those places, and here we also used a lot of other data sources. We identified home of individuals using the same method as before in the case of Twitter, and used real estate prices to infer socioeconomic status. But the story was that we found that basically those those locations in the city that have a specific amenity portfolio observe significantly higher mixing of individuals, and this specific amenity portfolio should combine the services in a way that it combines a diverse pool of services that are difficult to find elsewhere in the city. Okay, so therefore we call it amenity complex because it follows really the method of Hausmann and Hidalgo in their famous paper in PNAS in 2009, in which they also identified economic complexity as specializing into those diverse products that are difficult to produce by others. So we follow the same logic in calculating, but here now the logic behind is that if a location has a complex amenity portfolio, then it serves a diverse pool of demand, right? Because then it has a diverse portfolio. So its diversity increases social mixing because people who need some stuff, I mean, it can serve diverse demand, okay? But if it also serves demand that is difficult to serve elsewhere in the city, then people should go there if they want to do that specific stuff, and therefore they will meet with other socioeconomic groups as well. So basically, that's the logic behind, and we see some correlations. So we think that this story might hold. So coming now to mobility and urban segregation, one thing that stuck into our mind with Gergő Pintér, who is a postdoctoral student at or researcher at the Corvinus University of Budapest, is that probably we should look into the effect of urban barriers in how what is their role in segmenting societies. So there are a lot of urban barriers that we can talk about, and we found that might be important. For example, rivers and railways are barriers that are difficult to cross, but also primary roads and secondary roads can be understood as barriers, right? So roads were built to connect places, but if the road is serving high-speed traffic, then local mobility across the road is very difficult. So therefore, urban roads might link distant places, but also might be barriers for short distances. And of course, administrative barriers might still play a role, because if you want to go to do your business, then probably you go to an office that it belongs to your district and not to the other district, which is just the others, which might be close to you. So to investigate this question a little bit, we constructed a network of mobility in Budapest, which connects stops of individuals where the individuals spend 15 minutes over the day. Then we call it a stop, and we link stops if the individual moves from one place to the other place. So this individual network can be aggregated to the city level, then which will be a very complex network, of course. But then we can run a community detection algorithm again on this aggregated social network, which will provide us with a grouping in which mobility within these detected communities is higher than mobility across these detected communities. Of course, the level algorithm has a lot of drawbacks. One of it is that you should play around a little bit with the resolution parameter, because at some level of the resolution parameter you get large communities, at larger level of the resolution parameter you get smaller communities. So I'm going to talk about a little bit about that. But here I just wanted to mention that if we detect these communities in Budapest, we see that urban barriers might have very different roles. So for example, with marker 1, you see a community which is crossed by a major highway, and I cannot really demonstrate it, probably by just showing this example above it, it exactly follows the district boundaries. In the other case, with marker 2, however, we find that the community that we detect exactly follows the line or the boundary of established by this major road. Okay, and with marker 3, we find that it really follows the boundaries of an island in the city. So these barriers, probably it's very difficult to like rank the importance of these barriers. These barriers might be at play parallelly with each other. So we try to quantify the role of such barriers. And here I just highlight one way of quantification, which is basically calculating within individual networks and on the aggregate level as well. And then this will be important in a later slide. We calculated the number of links that cross a barrier, but still doesn't cross a community boundary, and compare that to those mobility movements that cross a barrier and also a community boundary as well. So if so, the intuition behind is that if this indicator is decreasing, then basically what we see that these communities fit better and better to the polygons that are bounded by these urban barriers. In this specific case, these are major roads. No, these are districts. Anyway, the indicator is nice because we can also quantify this on the aggregate level, but then we can also quantify this on the individual level. And it also gives us the opportunity to decompose that by the characteristics of origin location and the characteristics of the destination location. So for example, we can also investigate whether individuals living in poor areas typically cross barriers, even though these barrier crossings are not likely, and we can compare to the and we compare directly to those barrier crossings that are likely because they fall within the same community that we detect from the entire network. So some of the findings tells us that there is a role of geography in how individuals cross barriers. So in this exercise, we decomposed our sample to the individuals who live within Budapest and to those who live outside of Budapest. And we see that the values across all the resolution parameters that we check, then we go from 1 to 10 with a fine scale. In all these, basically all types of barriers, we find a higher value for individuals who live outside of Budapest, which basically means that if they have to come to the city, they will come to the city and know whether what barriers they have to cross. They have a destination and they will go there. However, those who live in the city are influenced probably more by these barriers, because probably they choose a different mean of transport. They walk, they bike, and therefore barriers have a bigger effect on their daily moves. So we see this for basically all types of urban barriers. But as I mentioned before, we also have this opportunity to decompose that on the individual scale, which can really tell us whether home location or the visited location characteristics have some explanatory power to tell whether individuals cross a barrier, an urban barrier, or not. So what we see is that, as expected from the previous plot, the further these individuals live from the city center, the higher the indicator is, meaning that basically the same story. If they are far away and they commute or they travel to other locations, they will cross barriers, even though these are not likely to cross based on their aggregate level. However, we see a different story in terms of amenity complexity. So individuals, and here I have always troubles with implementing the coefficient. So let me just say that we find a significant relationship with amenity complexity and barrier crossings. So closing up, I would like to close with this video, which is from Meeting Places. So that's a classic American comedy in which the poor Eddie Murphy meets with the rich Dan Aykroyd, and he gets into these strange situations. So he gets into this high society while Dan is facing problems, just following the sequence of events that comes from meeting on the street, right? So this story is not without conflicts, as you see. I mean, there's a lot of trouble in how these individuals, the rich and the poor, communicate and understand each other. But at the end, they understand each other, and as you see in the video, they kind of fulfill the American dream and get very rich together. So I like this story because, of course, it's just a fiction, and kind of understand how this might happen. I mean, how bridges between the rich and the poor can help to fight inequalities. I think that's a nice illustration. Of course, that's just a fiction, and we need research to understand whether this is possible or not. And I think I don't have time to go into this, but I think one of the major areas that we should really build on is network diffusion. So I think we should ask questions whether diffusion in fragmented societies or fragmented networks is how that contributes to growing or decreasing inequalities. So what is spreading is critical to determine, of course, and how does that correlate? How do spreading correlate with economic mobility, the divergence and convergence of such fragmented networks? How does this relate to urban structure, as I tried to outline a little bit previously? I think these are questions that are very intriguing and worth to investigate. So with that, I would like to thank your attention and just collected researchers from ANETI Lab, and I'm very much looking for your questions and comments and to meet you guys in person.
Thank you so much, Balázs.